16 says Reina has 5 coins worth 10 cents each and 4 coins worth 25 cents each. I'm not sure why they don't just come out and say it. I guess they don't want to assume that you know what coins are worth 10 cents and what coins are worth 25 cents, but I mean, come on. Let's simplify this first sentence and just say that she's got 5 dimes and 4 quarters. Okay, the dimes are worth 10 cents and the quarters are worth 25 cents. If she chooses 2 of the coins at random, what is the probability that the 2 coins combined will be worth at least 35 cents? So as far as like what could possibly happen if you're just randomly picking 2 coins, they can either be 2 dimes, 2 quarters, or 1 of each. The only combination of those that will not be worth 35 cents is if we pick 2 dimes, right? 2 dimes, 2 10-cent pieces are going to be worth 20 cents. But if we pick a dime and a quarter, that gets us up to that 35-cent mark. So I think the easiest way to approach this problem is to kind of find not the probability that the 2 coins will be worth at least 35 cents, but to find what's the probability that we actually don't get that, and then subtract that from 100%. So let's calculate the probability of getting 2 consecutive dimes. Okay, so the probability is calculated by computing the number of desired outcomes divided by the number of possible outcomes. All right, this is how you calculate probability in general, just a simple probability. How many options will give you what you're looking for divided by how many total options are there. So if we want to find the probability of picking 2 dimes in a row, which is the only case in which you wouldn't get at least 35 cents, we will say, okay, well, the probability of getting the first coin to be a dime, since there are 5 dimes in this pile and a total of 9 coins, the probability here is going to be 5 over 9. Now, that's just the probability of picking a dime first. When we have these combined probabilities where the second event depends on the first event, you have to think about how many possible outcomes are you actually left with, right? So we pick 1 dime. The probability of the second one being a dime, well, since we've already picked 1 dime and we've removed it, there's only 4 dimes left, and there's only 8 total coins left. So on that second event, for the second coin, there's a probability of 4 out of 8, or a 50% chance. Now, this is a combined probability problem where we're not just calculating the probability of 1 event, but 2 consecutive events. And so the way that you combine these probabilities is to multiply them. Okay, so if I multiply these fractions, what this is going to give me is the probability of picking 2 dimes in a row. Okay, so I'm going to say times 4/8, which is really just 1/2, but I'm not even going to bother reducing it because these numbers are just small anyway. Okay, so let me make a note here. Here is the probability of picking 2 dimes in a row. And I'll make a little note here, without replacement, meaning we're not going to put the dime that we picked back. So 5/9 times 4/8 is going to give me, let's see, 5 times 4 would be 20, 9 times 8 would be 72, and we can go ahead and put that in, well, you know what, let's just, let's go ahead and reduce this, I think. So 20 over 72, what would that reduce to? I'll put that in my calculator here. 20 over 72 going to give me, let's see, both of those are divisible by, let's just do one at a time here. You know, forget the calculator. Let's just divide by 2. That'd be 10 over, what would that be, 36. And then divide by 2 again to get 5 over 18. Okay, so 5/18, right? And we can calculate that out of 100%, but really that's what we're looking for. Okay, so 5 out of 18 potential events are going to give us 2 dimes in a row. Now to figure out, well, we want kind of the other side of that, right? We don't care about, but the question here is asking, what is the probability that you get at least 35 cents? And so that's going to be all the other possibilities, right? There's a total of 18 total possible outcomes here, where 5 of them are going to be picking 2 dimes in a row. So the probability of picking 2 coins that will be worth at least 35 cents. And again, without replacements, is going to be 1 minus this. So in other words, it's going to be, well, all 18 outcomes, right? So this would be 100% of all the total outcomes, minus those 5 outcomes, that would be the 2 dimes in a row, and that's going to give us 13 possible outcomes. This is going to give us our answer here, 13 out of 18, which is going to be the probability of picking 2 coins that add up to at least 35 cents. Well, that's it for number 16. Thanks for watching, and have a great day.